Hello,
Hi,
Aaron.
how are you doing
Welcome.
today?
Doing great, doing great. We're
Awesome.
excited to have you here.
Thank you. Thank you for having me, Danielle and Lisa. I'm really excited to do this workshop, talk to folks about things that they can do with Pulumi. Shall we get going?
Absolutely. So we'll be here hanging out in the background. We'll jump in if there's any questions, if you don't get to them, and off you go.
All right, thank
Thank
you.
you.
Yeah, should be sharing my screen now here, and we'll be focusing on this view for most of the talk, alternating between some slides and, of course, some hands-on programming. I'm here from Palumi to talk to you about 6 pearls in 6 programming languages to program the cloud. I want to start off with, of course, I think Palumi's greatest strength, which is our first pearl, bringing your own language. So I've got an example here on the right of some Java code. We'll actually see that in my editor very shortly. And everyone has been asked if they want to follow along to prepare their own Kubernetes cluster. We're going to be deploying, just show that I have nothing up my sleeves, that I'm going to be deploying a cluster actually live. So say a little prayer to the demigods for me using Civo. And I'm going to be doing this in Java. And I'm going to be showing off some of the things that we can do given that we're using real programming languages and we're projecting out cloud provider resources into each of the languages we support. What this means for you is that you get to use all of the existing tooling that you have, linting, formatting, type checking, any special libraries that you're using to improve your own code quality, you can apply those just as well to Pulumi. So let's just see what that looks like here. I'm going to switch over to an empty VS Code window. I've got a directory here. I'm going to start by creating a new project in a subdirectory. So I'm going to create one cluster live and CD into that. And I think sharing my screen on my editor is slowing down my computer a little bit. Probably should have used a more powerful desktop for this. I do want to stress, if you already have a Kubernetes cluster, you don't need to do this step. If you do not have a Kubernetes cluster, it's pretty quick to sign up for Civo, and you'll see that you can get a cluster going in just a couple minutes. So in this one cluster live directory, I'm going to Pulumi new up a template that we already have. So I'm going to be using this URL, which I can paste into our comments as well. Maybe I cannot paste, but maybe someone else can paste this. All of my slides should say github.com, Aaron Friel, and Civo Java is the template we're deploying. And what this will do is pull down a template. It'll ask me for a few questions here. I need to put in a token. And we'll talk a little bit in a moment about the secret handling that we have within Pulumi. Give this a second.
Yeah, and Aaron, sorry, what was it that you wanted us to paste in? And yes, we realize that this is a limitation as platform that the presenters haven't been able to paste. So you can either paste a private chat and we can copy it over, or you can just tell us and I'll type it real quick right now.
Yeah, it's this github.com/aaronfriel/civo-java. So this whole Pulumi new command, I guess in private chat I can paste it here.
Yeah.
Awesome. There it is.
Today.
Got
Yeah.
it.
All right, you're good.
Get it in there for you. Okay.
I think something about sharing my screen and maybe this live stream is using a lot of my laptop's horsepower. So this would ordinarily be installing some dependencies.
It's a known thing. It's just the Hopin platform is just a heavy footprint. Sorry about that. If you have any other things running in the background to turn off, that might help.
Yeah, I've already tried to minimize everything else that's running. We're waiting for this command to complete here. Okay. All right. So I didn't do anything magic while the screen was down. Our configuration saved, and Pulumi has gone ahead and also installed Maven dependencies here in this template. So just take a quick look at this template. Again, you already have a cluster. You don't need to do anything here. This is just me showing there's nothing up my sleeves. If you don't have a cluster, feel free to get a Civo account, get going. You have about 5 or 6 minutes before we'll move on to deploying some things into a cluster if you want to join us. So just to start out with, this looks like plain regular Java. We've got a public class. We've got a main function. It invokes this stack with a context, and then it deploys some resources. I can see that these resources are valid resources. I might have to restart my editor here in order to get code completions. So let me just reload the window. Benefit or pro and con of using language servers and protocols is we're relying on all the tooling that is already existent for languages. So hopefully in a moment we'll get some code completion and hover on these. I want to point out that Java is one of our newest supported languages. Kind of fitting for us to deploy a Kubernetes cluster in Java. I think the lore is that originally Kubernetes was a Java project before being rewritten in Go. Great. So now I've got my code completion. I can hover over these builders for the arguments. I can get code completion here and see what are all of the options available. This really lets me explore infrastructure while I'm writing it, figure out what my options are, learn a little bit about some of the resources that are available, what they take, and then of course plumb things. So for example, this firewall is a prerequisite for this Kubernetes cluster. So we're going to pass in the firewall ID, getting this output of string. We're going to then export a couple things from this cluster. We're going to export a cluster name and a kube config so that I can access it for the rest of the demo. So let's go ahead and Pulumi up this cluster. This is working much better with a lower resolution screen. It seems like things are moving a lot more quickly. While this is deploying, this will take about a minute. Does anyone have any questions about our Java and our language support that I could answer? Got a vamp for just about a minute and a half here.
You can just tell us what your most frequently asked questions are and start answering them. People are, sometimes it takes a minute for folks to get to find the chat in the. And by the way, one thing I want to say is with the platform yesterday was multiple places to ask questions. So hopefully everybody's figured out that we can only see the comments. So if there's any other chat areas, like I think there's an event chat, there might have been a Q&A, make sure you type the questions that you have in the comments section, because unfortunately that's the only thing we can see. Anyway, Aaron, what is your most asked question?
Probably about Java support in particular is, can I use, and this is a question near and dear to me because I am a former Scala user, is can I use other languages with our Java support? Yeah, so we are publishing our SDKs for Java. I think we're targeting Java 11. So if you're used to adopting and reusing plain Java within Kotlin, Scala, or any other JVM language, you can use it. You might have to take, we do this builder pattern because we don't have things like really nice constructors with optional arguments and things like that in plain Java. So we are looking at, options for maybe a Kotlinized version of our SDKs, just to be a little easier to use.
And then you've got another question. How easy is it to move from Terraform to Pulumi?
Yeah, we have a variety of tools to do this. So we have a tool called TF2 Palumi that we're continuing to invest in that helps migrate an existing Terraform project over to Palumi. We'll actually do a lot of code generation. You'll see some of that later. And that way you can ideally import your resources into Palumi. I find that it's easier typically to just go greenfield. We have some folks who have done things like use outputs from the Terraform side of things to then treat those as inputs into Palumi stacks, doing sort of a composite approach of migration. And of course, you can always talk to Palumi sales and we can talk about, your particulars. And I would mention too, TF to Pulumi and everything you're seeing here today is open source. You're welcome to peek under the hood, figure out if you can contribute. We're always looking for new community contributors, new language support. This Java support was actually a collaboration between Palumi and one of our partners as well.
What's the next language that you want to work on for support?
That's a great question. I think probably Rust. It's a trendy language, but I think it's a language that I've really taken to, and I think it'd be interesting to explore what an API for Palumi would look like in Rust.
Yeah, Rust came up a lot yesterday because it solves a lot of security problems that some of the other languages weren't quite as good. We had a little Rust versus C++ debate in the chat yesterday for those of you that were on yesterday as well. And then it looks like Raphael says, how do you manage multiple provider account, provider/account, for example, dev/QD? Sorry, it's really
you might have seen, might have missed it as well, is that when I created this project, it created first a Pulumi.yaml. This is just sort of a description of what the project is, what runtime we're going to be running it under. This is the project file. And then when I created this template as well, it prompted me for a Civo token, which it put into a Pulumi.dev.yaml. This is the dev stack of the overall project. We can have multiple stacks, and those can have their own unique configurations. You can see this token. This token is encrypted. It's obviously not easy to see. This is not the actual Civo token, but this is encrypted by our service, or could be encrypted with a passphrase to separate out those different levels of access.
Questions are flying in now. I love it. How many cloud providers does Palumi support?
We, of course, support the major cloud providers, whichever set of you want to define that as. I think we cover all of those. We have about 100 providers in all in our Palumi registry. And we have, I think, we've had a pretty good pace of 5 to 10 new providers a week for the past few weeks, where community contributions, new providers for new SDKs, and we're also working on building some new tooling to make it easier to contribute providers. The cluster here is deployed, so I think we can move on. We can go look at what it looks like to deploy some things into this environment, and we'll move on to our second Perl here, which is I need to switch screens. There we go. Second Perl of Palumi here is don't reinvent the wheel. There are, according to Artifact Hub, over 10,000 Helm charts available, or I think that's a combination of Helm charts and some other things, but over 10,000 packages available. We integrate with those with a helm.release resource, so you don't have to reinvent the wheel. You don't have to start from scratch if you're going to be deploying things into your cluster. If there's an existing chart to deploy some open source application, feel free to use that. We will support that in the Palumi CLI and our SDKs. And then if you want to then create your own components entirely within Palumi, some folks are not as fond of the Helm templating language and might want to use one of our languages. Because we're using real programming languages, you can publish components. It's just a library. I could write a NPM module or a Python package and package together, sequence a few different resources together, just export a function to create those. Or we have this tool at Pulumi.com for how to deploy a package, which is the same thing that we're using throughout here, where I'm using one provider to deploy a cluster from Civo, our Kubernetes provider. Those are both packages. And what distinguishes a package from just sort of a library is the package is projected out into each of the languages we support. So you can use it across all languages. I see a question here about why not supporting Java on day one. I think it's just a matter of resources. We're a startup. We're trying to get going. I think some of the first languages we supported were TypeScript and Python. Those are really popular languages for engineers, especially system administrators and operations folks. We grew that to Go, .NET, and now adding YAML and Java this year. So let's look at what it looks like to deploy a Helm package here. So let's just switch over. And before I get going, what I'm going to do is I'm going to output my kubeconfig into a file. So I'm going to use that kubeconfig that I just created with this cluster and write it into this file. I won't show you the file because it has some credentials in it, but then we're going to export my kubeconfig environment variable so that I'm using it throughout this. So let me just do a kubectl get all namespaces. This should be a pretty empty, bare bones cluster on Civo. Yep, pretty much everything deployed in kube system and just the Kubernetes service in the default namespace. So with that set up, I'm able to deploy things into the stack. I'm going to make dir to Helm live. And for this Perl, I'm going to be using our Kubernetes C# template. I'm using these templates because they take care of a few things for me. One of which is they prompt me for a few steps to get going so that way I can just have a template with some dependencies already pre-installed. I'm just going to enter through here. This will invoke NuGet to restore packages and give me a complete project directory here. Once I have that, I've got a C# project here, but I'm actually not going to use most of this. So you might have seen on my slides, github.com, Aaron Friel, kubecrash Perls. I'm using source code from there throughout this talk, and I'm going to be using that here to show what creating a Helm chart looks like. So I'll just get rid of this deployment that's already there. Got a few things imported that we are not going to need, and we're going to use Pulumi. We're also going to need systems.collections.generic to create a dictionary, and we'll use using Kubernetes equals Pulumi.Kubernetes so we can import things with a little bit shorthand. Again, real language support. So I'm just going to type new Kubernetes. I get code completion here. I'm going to do a Helm v3.release. Here's nginx. And declare some arguments here. I'm just going to copy a snippet of what my arguments are going to be. And so this is declaring that we're going to use the Helm deployment engine, deploy ingress nginx into our cluster. Just going to fix the formatting here a bit. And we're going to use the upstream ingress nginx repository for this, have it create the namespace. And we're going to use the default values for everything. We're pretty happy with that. So with that selected, run Pulumi up. So what it's doing here is it's building the .NET package. It's running that code against the Palumi engine and going to then, when it runs live, run this release using Helm's SDK. I really like being able to build off of the wealth of packages that are out in the Artifact Hub ecosystem elsewhere in Helm. My favorite packages to get going on a new Kubernetes cluster are the Ingress Nginx, Cert Manager, another sponsor of KubeCrash over at JetStack, and then, of course, external DNS. But with those three, it's really easy to get a Kubernetes cluster online, internet accessible with TLS. We're not going to do that here because that would require us spinning up external DNS, having a Route 53 or a Cloudflare or something like that configured. This will just take a moment. This is using, again, this is effectively invoking that Helm release engine to manage state and deploy this chart into our cluster. Now I should be able to do a kubectl get n admin ingress nginx. We'll just do a get all. I can see that I've deployed this nginx controller. I've got an external IP already. And so we're ready to go to deploy some applications into this cluster and have them be internet accessible. That'll take us to our next Perl, safe and simple secret management. Secret management is probably one of the hardest parts of doing software engineering well. There have been some pretty high-profile attacks on large companies recently, largely related to keeping secrets in the clear. And we have adopted an approach from first principles that secrets should always be encrypted. That should be a super low friction path to getting secrets into your Pulumi program, and that way anyone in a team can contribute a secret value without having to, ask some other team to create a new secret or do something like that. Like our philosophy is that you should be able to create secrets extremely easily, and then maintain them as part of the Pulumi stack. Show you what that looks like in a Pulumi program. We're going to do we're actually going to use Pulumi YAML for this program, and we're going to deploy just a few things into a stack. We're going to deploy, we're just going to deploy a namespace to deploy our application, and we're going to show how we can plumb that kube config that I had earlier into a provider, and then we keep it actually secret even in our state file. So I'll make dir3 namespace live, cd into that directory. And then I'm going to do Pulumi new Kubernetes Yaml. YAML is another one of our new languages that we support this year. It is our simplest language, and it's, I would say, my pride and joy is just getting things going in YAML is so quick and easy. I think it's really great that we support every sort of real programming language. We don't distinguish between configuration languages and programming languages. Like, this is a programming language. We have expressions, we have syntax, we have grammar here, and real work gets done in YAML every day. We want to respect that and build tooling for people who want to write YAML to deploy infrastructure as code. Like our other templates, I just kind of ran this Pulumi new in order to get a bare bones starter up, but I'm going to be changing most of everything in here. So start off, I want to deploy a configuration block. Configuration block so I can declare that I'm going to have an input config value that is a secret. We're going to say this is Kubernetes kube config, and we're going to say it's a type of string and secret true. What this does is it ensures that as Pulumi executes this program, anything that uses this config value, as you'll see in a moment, will automatically encrypt that value. Even if we transform it in some way, the transformation will also be encrypted. So this really comes into play when you have things like you have a token that you need to embed into something like a bearer token sort of string. This will then, if this token is marked as a secret, this entire string gets encrypted into your state file. So we're going to get rid of the resources here. We're going to declare a Kubernetes provider. I've been relying on ambient Kubernetes credentials, so like my kubeconfig is set up to talk to the Kubernetes cluster I just deployed. But if you want to go explicit, we can deploy things like a provider explicitly. I'm going to set this as the default provider for this project. This is a YAML specific behavior because we can statically analyze the entire program start to finish. We can support things like setting a default provider and ensure that we do that at the beginning of the execution of the program. And then for properties, I'm going to say kubeconfig. Oh, excellent. I think this is probably provided by Copilot code completion here. Not quite. It'll be Kubernetes kubeconfig. So in YAML, our syntax is any key in configuration, resources, or we haven't declared one yet, but there's a variables block that you can declare as well. Any key can be used in an accessor like this and interpolated into a property. let's also declare a site or a namespace using this. So we'll Kubernetes, and I'm going to hit Command space and get my completion here. And you can see that I've got completion for the Kubernetes API service. This is given by our language server plugin for Pulumi YAML. So I can go in here and I can say core v1, and I want namespace. And for properties, say just the name is awesome site. And then we'll fix this last. So we're actually getting, even in YAML, we're getting some error checking with that language server. So we'll say we want awesome site.metadata.name as an output, just to prove that it is deployed up. I did not set the environment or the config var. So in order to set this in my stack, I need to Pulumi config set secret Kubernetes kube config. So this is the key that we're setting, and then we're going to provide the value, and I'll just do a cat of kube demo config. And this will create a pulumi.dev.yaml with my encrypted config value. Let me up. So if you're doing this, if you're following along, you would use just your kube config value. So I think that would be, I think it's just kube config all lowercase. Just config. Okay. Pulumi YAML is extremely quick to deploy. There's essentially no compilation step involved, so we're able to just invoke the provider directly and create a namespace. We should now be able to do kubectl get namespace, and we have our awesome site namespace. So this is how we can use secrets. I do want to show also that we're actually keeping the secret encrypted in our state. So I'm going to use a command called Pulumi stack export to view our state file. Normally this would be stored in the service, or if you use a Pulumi login with a local file state backend, it would be stored as a file. But even then, Pulumi stack export is going to show me that this value ends up being ciphertext with some metadata about where that key lives, or salt, we'll store that metadata that we need to decrypt it, but we won't store the key. That's the key thing, is that this pulumi.dev.yaml file is safe to commit to your repository, to share if you have a team that's all accessing the same stack. And you need either that passphrase or the Pulumi service account shared with that stack to be able to decrypt and use this stack and this encrypted value. Clear that and go to our fourth Perl. All right, let me just check if there's any questions as we're going. I see we got a few folks from the team also replying, so thank you, Levi. Going to the fourth Perl, which is multiple clouds, one tool. With Pulumi, we can deploy across multiple providers in the same program. This enables application developers and owners to keep the database, the queues, the S3 buckets, anything that's essential to their program deployed locally and in the same infrastructure as code as their application. This, is part of shifting left. It's really important for velocity to be able to enable engineers to take initiative to deploy the infrastructure that they need for their application. And we can then do this, using the secret management. You just saw flow connection strings directly from a database, say hosted in AWS, to a secret in Kubernetes. And we can also use things like stack outputs to allow multiple stacks to actually use Pulumi's service as a key vault, as a method of sharing credentials between multiple stacks. To see what this looks like, we're going to open up a new program. I think for this one, we're going to use Python. I will apologize. You may want to go to the kubectcrash Perl site here and look at the sample code. This is, when we start deploying stateful sets and secrets, that's quite a lot of code to type in and to sort of copy from a screen. So feel free to use the GitHub repo to sort of follow along and copy snippets. So I'm going to make a for DB live directory. I'm going to do a Pulumi new Kubernetes Python. This will, by default, create a virtual environment, install dependencies again, set me up with a starter program. I'm going to change a couple things real quick, though. I'm actually going to throw away this virtual environment and then have it create a new one for me. Once this is done, I'm going to add to my Pulumi requirements here our random resource provider. This will allow me to generate a random password and store it in state. And then we're also going to use Pulumi Kubernetes to store the secret for a database to access. So I'm going to just RMRF my VM sure. When you're contributing to a Pulumi project, you don't need to commit your node modules, your VM, et cetera. On Pulumi up, we will install dependencies automatically. So I'm just going to take advantage of that to really quickly install without having to activate my Python environment. I really like just being able to use the Pulumi command if possible, even if it's a little bit inefficient here. So this will create a new venv. This will also then, this will deploy the default template. I'm actually going to say no to this. I'm not going to deploy that. But now that I've got the random provider available, again, I'm going to largely get rid of the template here and using that repository as a guide, I'm going to deploy a few things first. I'm going to say initially, I would like some random passwords here. So I need to import Pulumi random as random. And I'm going to go ahead and tell VS Code as well that it can find an interpreter so that we can get these squiggles to go away. So I think I just tell it to use this Python 3. Excellent. Okay. So first, in order to sort of simulate me deploying a database in the cloud provider, a hosted database, I'm just going to use some other provider as an example of flowing data. In this case, we can imagine that instead of a random password for the database, which we're going to deploy in the cluster, this could be a AOS RDS instance. This could be a Cloud SQL instance. And we're just taking the connection string off of it and flowing it into a secret. I'm going to have to declare a secret resource to store this. So we'll say secret resource. And I need to import Pulumi Kubernetes as Kubernetes so that I can get this. And then I should be able to say core.v1.secret. We'll just give this a name of secret. And I'm just going to copy my snippet for some of the internals here. So we do want this deployed in our namespace. So we'll give it a metadata and a namespace. We're going to then use the string data property here. So ordinarily, for folks familiar with secrets in Kubernetes, the data field would be base64 encoded. The string data field is going to be for raw string data, and then we'll take care of the base64 encoding as we insert the resource into the cluster. Just continuing on, in order to deploy a database, we have a service that we need to deploy and a stateful set. So using my repo as a template here, I'm declaring a service with some metadata. I'm declaring some port information. We're going to use a MariaDB database with a default port in our namespace, and then we're going to deploy a stateful set with that database. And actually, I've taken a lot of this from the Kubernetes guides on how to deploy stateful sets. So I'm following pretty closely what the Kubernetes documentation has for their example for deploying a WordPress application in a cluster. I'm going to copy a big chunk of stateful set code here. For folks familiar with Kubernetes, this is one of the more verbose resources you could deploy. There's a lot going on here, but I want to point out that we have things like we have keyword arguments, we have types. And if I install something like MyPy, I'm going to get checking on this. We're trying to make sure that you're able to write high quality Python code, even if you're writing it against something like Kubernetes, where we have really deep property trees, lots of typed arguments here. We're going to deploy MariaDB. We're going to make sure that we use MySQL style authentication because we're going to be deploying a WordPress database that just kind of expects default MySQL. We're going to declare some environment variables in this. We're going to flow, not using Pulumi, but we're going to flow using Kubernetes own secret handling, the secret into that resource. For both the user password and the root password, we're going to do some isolation here between root and the WordPress user. Ports and volume mounts, persistent claims, all of this is supported by default with our resources. We just largely project the existing Kubernetes API here. Last thing here is I would like my next step, the next Perl, to be able to use essentially the connection string from this deployment without having to, say, copy and paste it and maintain that link. So I'm going to go ahead and also export a few values from this stack. That way we can reuse that in the next program. With all of that written, I do still see some squiggles here. I'm going to just hope that this is maybe the language server maybe incorrectly thinking that we don't have that package available. Yeah. So with this, we're going to deploy those two passwords. We're going to deploy a secret, a service, and a stateful set. We'll get some outputs here. Some of these are not known. This DB password, for example, is not known yet. So we'll create it as we go. What you're also going to see here as you deploy this is we have some functionality in our Kubernetes provider to also block and wait for resources to be up and running correctly before continuing. The Kubernetes sort of philosophy is throw a bunch of resources at the cluster, let operators and controllers figure it out and reach equilibrium. However, for the purpose of ordering operations, if you want your database up before your application, and that might be important for avoiding downtime, we have a default awaiting functionality where we make sure that the service here didn't resolve until it was actually targeting a pod in that stateful set. So we made sure that the selector on this service actually found an endpoint before we completed this stack. You can also see here that the database password is marked as a secret. That's important. Again, we're flowing secrets through top to bottom in our stacks. That takes us to our next Perl, and I will also use this as an opportunity to look at if there's any questions. Mike says, asked if this will be shared afterward. I think Danielle and Lisa, said that the recordings will be available next week. And also all of this source code is going to be available on my GitHub, linked here at the bottom. Our next Perl is going to be sort of the opposite. Instead of composing multiple providers and dependencies into a single stack, we can use Pulumi to also break up the infra monolith. This is significant because it allows us to practice least privilege correctly. We can avoid disastrous mistakes like the equivalent of RMRF of root is running Pulumi destroy, -- yes, and just skipping all prompts before destroying a stack. So it might occur to people that maybe this is a contradiction of the third Perl. Should I compose all of my stacks into a single program, or should I separate them out? And I think just like the monolith versus microservice debate. There's not a single right answer. The first stack that I deployed today was the Kubernetes cluster. It really makes sense to me to keep that in a separate cluster from the applications that I'm going to be deploying in it. Every other decision is going to be on a case-by-case basis, and I think one of the strengths of Palumi is that we're not prescriptive over how you structure your code. I also want to give a shout out to Thomas Kadar for this wonderful. Why not give everyone administrator access? What could go wrong? Let's switch over and deploy a stack that's going to use stack references. We're going to actually deploy the WordPress application using the database that we've just deployed. And I think for this application, we're going to use TypeScript. So let's go ahead, cd up. I'm going to make there a 5 WordPress live. And we're going to Palumi new Kubernetes TypeScript. Enter through all of these prompts, let it install some dependencies for me. By default, we use NPM, but you can opt into using yarn. We both have an environment variable you can set, and I believe a flag in the Pulumi.yaml file if you want to use yarn. Instead, I think either are really great tools. Support for other package managers like PNPM, I'd recommend heading to our GitHub repo Palumi/Palumi and file an issue if you find something that's not working. There's a lot of experimentation in this space on the node side, so we're supporting the major package managers and exploring what future support for other package managers would look like. With this, this actually is pretty close to what I would like. We're declaring some app labels and a deployment. This is a lot closer to what we really want to deploy. We're still going to add a few things here. So I'll start out by first declaring a stack reference. So I can refer to the 4DB live stack that I've just deployed and use its outputs in this stack. So I'm going to do a new, I need to import Palumi from Palumi, new Palumi.stack reference. And if you're using our service, these stacks support role-based access control, so you can give or take away access to stacks and their outputs. If you have any secrets or sensitive data, you can control that with the service as well. So the name for this is going to be, this will require you to run Palumi about. I'm running Palumi about, and I'm seeing that my current user is Friel. So the stack name is going to be my organization name or username. They are equivalent here. Friel, because I'm deploying this into my own service account, followed by the project name. And the project name for this stack was 4-db live. So we're going to use that. And then we're going to use the stack name. So by default, we deployed into dev with each of these stacks. So Friel 4-db-live dev. This will reference the stack that I've just deployed with the database and allow me to access the DB user, DB password, things like that. For the deployment, we're going to put this into a secret first, so we don't have that password floating around in plain text. Make that KAS. So we'll deploy a secret. We're going to use the DB password, and we're going to take the outputs of this, which is a dictionary of string to any. It's just going to be some collection of outputs, and we're going to access the DB password. We have to use an apply here, I think, just because of the typing. Ordinarily, we would do things like allow this, but I think for this particular resource, we need to use an apply to just nest into to get that value out of that dictionary, because this, until we actually run the up, we won't know what the value of this output is or how many keys it has on it. Now to deploy the WordPress stack. So we'll call this deployment WordPress. I'm going to, again, copy a couple snippets over here. First, let's make sure that we deploy this into our awesome site. Namespace, give it a label for selectors and replicas. Let's go ahead and put replicas as 1, match labels. And we can actually use this app labels here. This is kind of a nice feature of using a real programming language, so I can refactor things out to an environment variable, or a variable rather. So I'm just going to use app labels consistently here for the selector. And then for the spec, let's see, selector replicas, we need to declare the image. Okay, we want to modify this spec as well. We want this container to be named WordPress, use the WordPress latest image for ports. We want port 80 name WordPress. For env, I'm going to copy a snippet here. Oh, I don't think that copied quite right. Let's copy the ports over again. Okay. I'm copying things at the wrong level. Let's see. We have template, metadata, and then spec. There we go. Copy this container specification. And I'm just going to run format document using Prettier to reformat this. We're declaring a container WordPress. We're taking in the 4 values and we're using those database outputs as well as the secret from our last stack. And then we're going to just export use the DB password from the secret. We then need to declare a service and a ingress. Just in the interest of time, I'm going to copy these again from that GitHub repository as a snippet. So this was named K8S. We're declaring a service to access this, a cluster IP service to access this deployment. And we're also declaring a ingress that's going to use the ingress controller that we deployed in the second stack. This is just going to be a wildcard ingress, so I don't have to futz around with host names. And this should make that database internet accessible, or that WordPress instance internet accessible. So we can see there is a stack reference in here, and we're going to be then using that to flow into our other resources. We're going to read that stack reference, and again, we're taking advantage of the awaiting functionality here. This stack won't complete until the deployment is up, that the service has an endpoint that it is actually able to hit. The ingress needs to actually have a load balancer configured. And when this is done, we should have an internet accessible WordPress instance. Wonderful. An awesome site, get ingress. I should be able to curl this. .302 not found, but it's redirecting me to wp-admin install.php. So if I curl that, awesome. So we have the WordPress setup. Just to show that this works here, I'll create a new tab and navigate. So here is the WordPress setup. So we've deployed a WordPress application on a Civo cluster using, so far, 5 different programming languages. And we are now able to manage this instance. Go ahead and click test. 1, 2, 3, 4. Go ahead and install this. I don't care too much about this password being visible. I'm not going to actually log in here, but now I should be able to go to the home page and see there's a WordPress instance. Takes us to our last Perl of the talk is one resource, multiple managers. Server-side apply is a feature that GA'd in 1.22 of Kubernetes. It's a fantastic feature that lets multiple managers of resources manage individual fields on a resource. So here, managing the replicas separately from the image. If we have a controller that's controlling what the latest image is for our deployment, and we want an operations team, say, to separately own how many replicas. This is functionality that enables Pulumi programs to modify existing config maps and namespace labels and things like that, where the Pulumi program shouldn't necessarily own the entire resource, but it should own, say, a particular label, maybe used for a security policy or a network security rule. We can then modify these resources repeatedly and take advantage of all the functionality that server-side apply offers. For this, I'm going to use Go, and we'll again just switch back to my editor and create a new stack. 6 patch live, cd into that directory. And like we've done before, I'm going to start with Pulumi new Kubernetes Go. Create this stack. This will give me a main.go. It's really close to what I want, actually. We're going to get rid of the app labels. We're not going to be changing any labels with this. But with this, we're going to show how we can use the patch resources to scale up our WordPress deployment. So instead of new deployment, I'm going to say new deployment patch, uses slightly different arguments. We'll have to give it deployment patch args. And there's a few different rules here. One is that we have to specify I'll go ahead and comment this out, get rid of those squiggles temporarily. One thing is we have to specify metadata, and we have to specify in particular a name and namespace for this resource, because we have to have a fully qualified name of what we're going to be patching. We cannot use the auto naming functionality here that Pulumi has. So name is going to be a Pulumi.string WordPress. Namespace, Pulumi.string awesome site. And I'm also going to add an annotation here, force patch or patch force. We deployed that original WordPress deployment as just a plain deployment, which means that that resource is fully owned by a single controller, the default controller for that resource. We're going to be using server-side apply here, and we're going to force Kubernetes to allow us to take over ownership of a single field on that resource. So for the spec, we don't have to specify the entire resource definition. Instead, I can say something like just replicas Pulumi.int 3, and I can then use this to scale up the deployment without having to override or specify any other fields here. Let's see. I think we also, in order to take advantage of this functionality, we need to declare a provider that we're going to use that has this functionality. It's currently in beta for us. So I'm going to declare also Kubernetes Provider, and that means I need to import Kubernetes v3 Go. So I need to import the top level package to create a provider that has server-side apply true, and set that as a option on this resource. So This will allow us to use the new API functionality in the provider. And let's go ahead and just call this WordPress scaling as well. And then additionally, in order to just see the status of this thing, I'm going to change the outputs of this stack to output the deployment status. We still have a squiggle here, but not used. Okay. Go is pretty particular about unused variables, and also I'm using Go workspaces, so I'll say Go work equals off to make sure that I can run this program up. So with this, what we should see is that when this program spins up, it will report out that we're going to be modifying a resource. It will say creating, created, but the resource that Pulumi is managing here is the patch state, and you can have multiple controllers. There's additional annotations that you can use if you want to control the controller ID that you apply for all of the fields that are managed. So you can have that way you can avoid conflicts. If you want to have one controller manage one set of labels, say for a service mesh, and another controller that manages labels on pods for a security policy. So we're going to say yes. This is the current status because this was the preview. And so we see that the observed replicas is 1, and we haven't so far changed anything with this deployment. When I confirm that I want to deploy this, we're going to see that we are now on generation 2, and we have 3 replicas. And if I do a kubectl and awesome site, get pod, I can see that I've got now 3 WordPress instances running. Those are the 6 pearls that I wanted to get to in this talk. There's actually a couple bonus things that I wanted to mention before we segue back to Danielle and Lisa, though. First, let's just present this. We can use that Go program that I just wrote, and this is actually in the repository if you want to check it out, to use an automation, to write an automation API, a command line tool that allows someone to manage Kubernetes resources. So go run main.go dev 1, scale that resource in the dev stack to 1. We can write our own tools. We can host them in a web server. We have customers who are using this to scale to multi-tenant SaaS services, to stand up buckets or databases per tenant, per customer that they have for that really strong isolation between them. And one last thing, if anyone has been following along and has checked out the repo, there is a directory called curtain. So what's behind the curtain is with this demo, you're not just getting 6 pearls in 6 languages, you're actually getting 36 programs written. I've taken each of these programs, I actually wrote them originally in Pulumi YAML, and I used Pulumi convert to generate every program that you saw today. There are a few idiosyncrasies. There's a little bit of code cleanup needed. Code conversion is not an easy art, but it is magical when it works. And being able to generate programs in 36 different sample programs in 6 different languages with only a few YAML files, it's an incredible force multiplier for writing examples and talks like this. I also want to give a shout out to the folks running the Palumi challenge. This is a tool that you can use to teach yourself Palumi and get a little cool swag at the end. Once you complete the challenge and you deploy some resources, learn what's going on in Palumi and what's possible with this language and tooling. The current challenge, I believe, is startup in a box. So you'll be deploying a static website and adding some additional checks to it as well. And I think that's it for my talk. This is all about cloud engineering for everyone, regardless of language, cloud, tooling. We really want to empower everyone to be a cloud engineer.
Aaron, that was a fantastic presentation and loads of people agree. Lots of like, thank yous. That was amazing. Can we get the recording so we can reference it? So thank you so much for being here and doing that.
You got a lot of love in the chat. In fact, everybody give Aaron a round of applause. I haven't quite figured out the emojis in the chat, but yeah, because I only speak in emojis if I have access to that. So it's probably a good thing for everybody that I didn't figure out that button.
Same.
So I don't see any additional questions.
And I think you covered them all.
I got it. So with that, we'll say see you later, Aaron.
Thank you so much.
Definitely scroll through the chat and reread. There's some great comments for you. This Prezzy's amazing. I mean, there's a lot of good energy. Yay, thank you.